Thanks everyone for joining today. We're going to run through a talk. We're going to talk about feature stores in practice. By the end of this, the goal is for you to not only understand what a feature store is, but also to really see one in action. And in this case, you'll actually see it being used to train a model in Databricks, while also being used in conjunction with MLflow and a few other tools. Um, At any time, if you have any questions, you should feel free to throw them into the Q&A in Zoom. If you're watching on LinkedIn or Twitter, you can also leave a comment there, and Shab from our team will be monitoring for questions to hand me. Great. Without any further ado, let's get started. So I'm going to share my screen. I'll try to share my screen. There it is. Okay. So like I said, today we're going to be talking about feature stores in practice. So we're going to train an end-to-end model with Databricks and Featureform and MLflow and a few other tools. So the agenda today, I want to start by first describing what a feature store is. I want to really break down the three types of feature stores that exist. And then finally, we'll go into the workshop. In the workshop, we're going to deploy and configure our infrastructure. We're going to build out transformations using Databricks. We're going to train a model on a training set that we'll define. And then we're actually going to deploy and serve to that model. For the model side, the training, the serving, we're going to use Databricks for infrastructure and use MLflow as well. So this will truly be kind of an end-to-end example. So let's get started by just defining what a feature store is. And to do that, I like to start with what a feature is. So a feature is an input to a model. So there are many different types of models, and models take inputs and generate an output. If you kind of squint and at a ML system, it all kind of looks this way. There are inputs that go into models, and those models are then used to make predictions. Examples of features include a user's favorite song, a store's top-selling item, average price of all items in a catalog. These are all features that might go into a model to make a prediction. So people use a feature store for there's kind of five things that people use feature stores for, five values that they get out of it. There's facilitating deployment, which I'll start by touching on, which is often one of the main pain points. Enhancing collaboration, organizing experimentation, increasing reliability, and preserving compliance. So let's start by talking about facilitating deployment. So if you're a data scientist, this will kind of ring true. If you aren't, this is kind of going to be a bit of a dive into how data scientists work. So data scientists work in notebooks. In notebooks, they will go and define, they'll usually download some data set, or they'll get it sent to them, or some other thing. Maybe they're actually interacting with it via SQL database. But they're going to be interacting with data, coming up with ideas, really just trying to analyze, even potentially train some models, and really just do the science part of data science. Just try to come up with things that they believe work and test these hypotheses. Unlike software engineering, if any of you are software engineers, with software engineering, you're kind of always building in one direction. Similarly, most of the code that you build when you're software engineering is production grade, or something that you would expect to actually deploy. With data science, there's like two modes. There's an experimentation mode and there's a production mode. And in experimentation mode, the value is more being able to really quickly iterate, test things, get the data you need to get, interact with it, etc. Production mode has a problem space that looks much more similar to like software engineering, like things like reliability, Things like uptime, things like monitoring become way more important. So as a data scientist, we'll eventually come up with our perfect feature in the notebook. We might have some local pandas transformation that we run on a small sample of data, like a CSV, and it works, or it seems to work. But then we run into a big problem, which is deploying it to production. You can't necessarily deploy a notebook to production. You kind of don't want to deploy some notebook with some pandas code, a mix of other kind of analysis code to production. So you almost end up having to rewrite and everything you just did to productionize it. Not only that, the tools that you'll use in production, things like Airflow, Spark, etc., are likely very different and much more nuanced and complicated, of way more options you have to set, way more potential failure cases than a local pandas notebook. And in many cases, it's not even your job to deploy it. You'll hand it to another team and it ends up being a lot back and forth. Point is as a data scientist, what we're trained for is building those perfect models and features in a notebook. But getting them to production is something that we don't really have a good workflow around. As you can see by this lovely fence in the middle of this image or this slide, we kind of work at the top, we experiment, we work in notebooks, etc., and we throw it over the fence to maybe even another team, at the very least a different environment, where we productionize the features. In production, we have to worry about things like potentially streaming, like on-demand features, like working with much larger data sets, like having to work with changing data, scheduling, job failures, all sorts of stuff that you just don't think about when you're working locally, all of a sudden become top of mind. So one specific problem to face is what I would call the 3 types of features. So in analysis and experimentation, the features are all batch. Like you're maybe just like have just a file or two that you're playing with. It's not changing. In the real world, data is constantly changing, 1, and 2, some of the features you have to build are on data you don't even have yet. So I'll go through the 3 types of features. So the simplest type of feature is a batch feature. Now, this looks most similar to what you'd be used to in experimentation. The big difference of batch features is that they also typically have a schedule attached, which means that there's an update. In experimentation, the data is static. Even with batch, the data is often changing. Even though you're not processing as each new event comes in, you might be processing every 24 hours. Batch is typically the easiest form of feature to build, but it's still significantly harder to build for production than it is to build in experimentation. Next, there's some features that depend on streams. And even though you can batch process a stream, like you could kind of collect from a stream and then every 24 hours process it, in some cases, we might have features that values change so quickly that you want to kind of continuously update them. So for example, if you want to know the last 5 songs the user listened to on Spotify, that's changing constantly. It literally changes every time a user listens to a new song. And in that situation, we probably want to have the value of that feature be very fresh, because we're going to serve it to a model, and the model will likely do much better if that value's almost up to date. So we might build a stream processing pipeline to build that feature and keep up to date. Both streaming and batch features in this case can be pre-processed. What that means is when you make a request, you don't actually process the feature at that point. The feature will already be processed and stored in an inference store like Redis, and all you're doing is retrieving it. Now, there's another set of features, which I'll call on-demand features, which are features that depend on data in the request. For example, if you are at Twitter and someone makes a tweet and you're trying to see if that tweet's spam. Well, the features with relation to the actual tweet won't exist yet until the time of the request. So you actually need to take data from the request and then featureize them there. So you can't pre-process those features. You can only process it at the time of inference. So these three things together, so streaming features, batch features, on-demand features, is kind of the full set of potential features. Again, in experimentation, we don't have to worry about any of that. We don't have to worry about data changing. We don't have to worry about running data at scale. Typically, there's just a lot of things that you don't have to worry about, which allows you to move very quickly, but creates a very like a chasm between production and experimentation. And so you end up with that pink monster. So there's kind of two ways that companies solve this that I've seen. One is that you have data scientists themselves write production grade code. In that situation, in fact, I've seen companies where they have their data scientists write straight up Scala and work at that level. Now, one, most data scientists don't have that skill set, so it's something they'd have to learn. And they typically won't do it as well as a data engineer because it's a different skill set. And two, it typically companies that do this also ask their data scientists to write all of their code to be production grade. And that just makes the experimentation process really, really heavy, which means that as a team, things don't move as quickly. And there's so much more focus being spent on productionizing things, even though most things are going to get changed or thrown away anyway. The other style, which I think is more common, is that data scientists take their notebooks, they have their examples in, and they hand it to data eng, and the data eng team gets into prod. Now, this has another set of problems. One set of problems is that data engineers won't typically be able to like really grok whatever the data scientists wrote in their notebook, especially if it's something a little more complicated. And there's not always a one-to-one translation. So there's a lot of kind of back and forth, figuring things out, trying to make sure that the code is the same. Now, if you end up imagine if you're a software engineer writing your code in Python when you're building and testing and working locally, but then when you need to put in production, you have to actually rewrite all of your code to Java. Like there's so many sets of errors and so much waste that comes into that process. It's even worse if there's two different teams. There's a team that builds and then the team that productionizes. So we think that both these things are wrong and that there is a third option, which is Featureform. And I'll get into how that looks. But the Featureform style is that the data scientists themselves would still be writing the production grade code, but the framework kind of allows you to choose the level of stability of like production grade that you want, which means that when you're experimenting, you can kind of take off all the guardrails and all the barriers so you can move really quickly. But then when you get into production, it's much easier to just put on and formalize where you need to formalize. So the ability to not have to necessarily always write production grade code or only write experimentation grade code and then pass it to another team, which has to essentially rewrite it. Having a framework that can do both and understand both is one of the things that we set out to do with Featureform. So the goal of Featureform is to write the logic once, change the configurations based on if it's production or experimentation, and allow you to move quickly while also owning your features and getting them into production yourself. So the next set of benefits from a feature store, I'll put them together because they're kind of related. One is enhancing collaboration, which means as data scientists, we can work together and share things and reuse things. And two is organized experimentation, which is much more about me, myself working, just making sure that my process is clean, understandable. Pretty much every data scientist at some point has looked at a training set that they built and kind of been perplexed at how they even built it. Like, what steps do I need to run to actually rebuild this thing? And collaboration kind of suffers because of that. Because if you yourself like kind of have a ton of ad hoc, messy, maybe things you memorize in your head on how to do stuff, then and you forget it yourself sometimes, there's no way you'll be able to collaborate with a team on it. Typically, what we see with collaborations, people sending like copy and pasting code or sending CSVs to each other over Slack, which is just a really unoptimal way to collaborate. Again, think of it like if you're a software engineer, like imagine like writing, not using stuff in like Git, but rather just sending files over Slack, or sending functions over Slack that you find useful. So I'm just going to explain this with a set of memes I put together because I know it's early and I thought this would be a little more fun than me talking about the benefits. It's so common that companies, with regards to documentation, it's all done somewhere else. Like it's done in like some spreadsheet somewhere. And what ends up happening, because again, features are very experimental, is things don't get documented. Or when they do, they change and the documentation doesn't change. So one core piece of Featureform is that lineage, documentation, versioning, ownership, all the relevant pieces of metadata are one in the code. So when you change the code, it will automatically update. And two, it can be derived. So we can just based on the logic itself, we can kind of figure out what this thing is, why you're using it, who's using it, what depends on, etc. And we can keep track of that metadata ourselves without forcing you to manually kind of go and update your documentation. Because what we end up seeing a lot is people getting their features to production, but in the process of doing that, they generate all sorts of just garbage, like untitled notebooks or notebooks of just kind of strange names or dates in their names. DF finals in their notebooks, feature table v7, a set of ad hoc shell scripts that they run in a given order to get things deployed. And finally, the documentation just not being there at all. So two more. One benefit of feature stores is increasing reliability. And what that means is there's a variety of things. Typically, when we talk about and think about reliability, it's in production as well. So after deployment. And the kinds of things that happen in production, one is that servers go down, networks go down, like all of a sudden your Spark just isn't working or it's overloaded. Data changes, like especially if you're dealing with streams or data that's just changing, which is most data. Data can drift. And as data moves, your models can actually become less productive and less effective. And understanding and being able to understand and increase reliability, very proactively. Typically, what happens is like people get a ticket, hey, it broke in this situation, or you can like kind of see that the model is starting to deteriorate, and you have to try to figure out why. With Featureform, we try to proactively show you what's changing and highlight things that maybe are worthy of your attention to make sure that you fix. Because the whole idea of pushing a feature into production without drift monitoring or any of the other pieces of reliability you'd need is kind of a sure pattern for failure. And it's a failure that you won't notice oftentimes until it's catastrophic. So having reliability, monitoring, all that stuff built in is crucial, especially if you're dealing with a model that is critical. Finally, there's preserving compliance. So with machine learning, you're often working really sensitive data. So there are tools like their data catalogs or other compliance tools or things like Okta. You would kind of work with all these things together to ensure compliance. The issue here is that all those tools are typically outside of my experimentation, outside of my notebook. It's just a very heavy and annoying thing to go and make sure I'm being compliant. And what ends up happening is either data scientists like on their own laptop will either just break compliance or they will follow it, but at the cost of productivity. And in Featureform, one thing that we have as a core piece of the framework is that all these configurations and integrations are built in so that you can just work as you're used to, and then Featureform will enforce all the compliance rules for you. So you don't have to think about it and you can't accidentally do anything wrong. Any questions so far? If there are any questions, please feel free to throw them in the Q&A. I'll make sure to answer them. And if you're on LinkedIn or Twitter, you can leave a comment with a question, and someone on our team will just paste it into the Q&A here. Okay, so I've talked a lot about the benefits of feature stores. Let me talk a bit about how Featureform works. So in Featureform, you will be working with a Python API. You'll be defining your features as SQL or PySpark code potentially in a notebook or in just a Python file. There's also a dashboard. The dashboard will give you data around distributions. It'll give you data on like monitoring. It will allow you to search and discover things, look at tags, share and reuse things, see lineage. Featureform is almost this like application layer, this framework that sits above your infrastructure. So we don't actually try to replace your Spark or replace your Redis. Rather, we provide almost like a feature framework on top of it that has built-in source of truth for these features, built-in collaboration tools, built-in monitoring and alerting, and built-in governance. Now, the whole point of features is to train models and to then serve for those production models. And so Featureform has APIs to do that. There's also a lot of automation we do. So for example, things like point in time correctness that we do for training so that we can actually build a correct training set. And also for inference, we make sure that things are cached in the right places. All the nuance about the differences between training and inference are abstracted away from you in Featureform. So Featureform is kind of like if you were to build a framework that does orchestration and metadata for features. And the data scientists or a data scientist would still work in PySpark and SQL and Python, whatever they're used to, but the logic would still run on whatever cloud, whatever infrastructure that you've used prior to Featureform. Cool. So everything I've described so far is relatively generic about feature stores, but in practice, one thing that we run into a lot when we talk to people is they'll have heard of a feature store before, maybe they've even used one, and they'll be really confused because all the feature stores seem drastically different, even though they all call themselves feature stores. And the reason for that is in practice, there are 3 types of feature stores. So when people hear feature store, they think of a database where features are stored, as the name maybe implies. And there's a category of feature stores, which we call the literal feature store, which the Databricks feature store looks like. The Feast is an open source unmaintained feature store looks like. So there's a set of feature stores that look like this. Now, their style is to you still write your own transformations. You still deploy things. Like you do everything yourself. The only difference is that you are storing those features in a unified place. So a lot of the issues we talked about with collaboration doesn't really apply here. Lots of things of organizing experimentation. Experimentation is done outside of the literal feature store. Monitoring, there's still some relevance here, but the monitoring of the actual pipeline is outside of the scope of the literal feature store. And governance and compliance is kind of out of scope as well. The problem is, in our opinion, a feature is defined as a definition. It's a logic. It's the SQL code or the data frame code or whatever code is defining the feature. That is what the feature is, the definition. In the literal feature store approach, the feature is a table. It's just like an output table. And if I just give you a table and say, here's the features, it's not really useful. typically, because most of the time we're going to be doing lots of feature engineering on those things. We might be editing them. And oftentimes the final feature might not actually be useful to you, but one of the upstream parts of the definition can be. So defining a feature as a table is often an anti-pattern. It's a pattern that a lot of other products have taken. Now, most companies that build internally build something that I would call a physical feature store. Others would call it like a feature platform, where they do their own transformations. They do the store. They do the whole piece, and we think this is correct. The only problem here that happens with feature platforms is they own the storage and they own the transformations, and they oftentimes come with their own transformation language. What that means is, if you're going to use one of these products, you end up having to rewrite all your features, and you oftentimes end up having to compute and store all of your data on some new proprietary data platform. And the concept of Featureform was what would happen if we took a feature platform like this, but we cut out the infrastructure. So we made the infrastructure be kind of plug-in. So you can continue to use your own infrastructure, but we provided a framework on top that made it all work together cohesively like a feature platform. So that all the resource repository, the collaboration, the governance, the monitoring, the alerting, all that stuff work together cleanly. And you don't actually have to rewrite your logic. The logic's still in SQL, it's still in PySpark, and it's still running in the places you expect it to run, so you get the same performance you would expect. But all the other pieces, the lineage, the search and discovery, everything else is what we provide. So this is the idea of a virtual feature store. Gartner actually recently released a new category, but they call it the logical feature store, which is the same thing. Like if you really read about it, it's almost exactly one-to-one a virtual feature store. Awesome. Any questions so far before I jump into actual code and show you how this actually looks in practice? If there are, like I said, you can throw in the Q&A. I'll make sure to answer them. Or if you're on LinkedIn or Twitter, you can just leave a comment or respond, and we will make sure to be looking there as well. Great. I'll keep checking back in on the questions if there are any. Okay. So I'm gonna move this so you can see my tabs. So let's look at code. Okay. So I here have a Databricks sandbox running. I'm gonna make it bigger. Put this away. Oops. Here, let me stop sharing. I know my thing's kind of acting up. Start sharing again. Okay. Share screen. Okay. In this example, we're going to run through a deploying and running something with Featureform. So Featureform will have already been deployed. If you can see, we have an internal sandbox here where we'd have our features, our entities, our labels, our models, our sources, all the users, role groups. You can see me. This is me logged into this. Yeah. So first thing we're going to do is just install Featureform, import it. So very simple. It's just a Python library. We'll create a client and we'll point it at one second. We'll point it at the internal sandbox. So that's just our sandbox. We're just pointing it at Featureform. Everything in Featureform is versioned. Similar to like how MLflow has this idea of like sending an experiment, Featureform has something similar. You can set a run, and it will be like, in this case, Databricks webinar. all of the infrastructure you have, you can register a Featureform. Once it's registered, it can be reused everywhere. So it wouldn't be expected that you would have to, register this stuff every time. Rather, you would register it once, and oftentimes you'd configure this when you set up Featureform. And every time afterwards, rather than calling register Spark, you just call get Spark with the name, and you can just use it. So all of this problems that come with getting your credentials in different places, keeping track of those, etc., all that stuff gets abstracted away from you. Once it's configured, all you have to do is call get Spark, get Redis, get whatever infrastructure you need. So here we're registering Databricks. Again, it's this local one that I'm using. I'm registering Redis, which I have running in AWS. And you can see when I register them, I call client.apply, and that creates them. You can see them getting created. In the dashboard, if I go to providers, I can see that Databricks. I can see what sources exist. I can see what features exist with it. Labels and training sets are already on this AWS Databricks provider. Cool. So Featureform has this concept of a data set. You can register primary data sets. So primary data sets are data sets where it's like from our perspective, are read only. It might be your raw data. It might be data that your data engineering team processed using Airflow or something, and now they gave it to you to use. But all the stuff that you would start using as a data scientist doing ML, like your starting points, your starting data, those would all be registered. You can register files, you can register directories. If it's SQL-based like Snowflake, you can register tables as well. So here I'm registering a file. I'm calling it in Featureform. The name is going to be transactions. This is the path. And then the variant, and the variant is like a version. Everything in Featureform has a version. If you don't set one, it will automatically be generated. And finally, everything in Featureform can be converted to a data frame. So every data set, everything can be converted to and from a data frame. So again, when we think about experimentation, rather than running an Airflow job, waiting for it to run, going, finding the file, downloading it, parsing a Parquet file, figuring it out, from Featureform's perspective, everything is really easy to convert back and forth to a data frame, which makes it really easy to register things and start using them and experimenting with them. If something is pre-registered, you can just get it. So again, in this example, I'm working as if it's like a blank slate. But everything here, like if I wanted to, instead of just calling register file, like here I'm registering file, and I can run cell, and you can see it's going to register. It's already been registered. I could also call get data or get source, and that would actually allow me to get the transaction itself. So this is a very simple transformation that I did on purpose just to kind of give you the simplest example. So all of our inputs, everything we build can be registered as we can build data sets from existing data sets by writing code. We support data frames, we support Python, and we support SQL. And it depends on the provider. So some providers like Databricks supports all three, but something like Postgres will not support data frames because Postgres natively doesn't support data frames. So here we have we're pretty much saying on Databricks, create a data frame transformation. The variant, which again is like the version, is called clean. We specified inputs, and then we specify the logic and apply it. Now, if I see this, I can go to my sandbox and I can look up transactions, and I can find transactions clean, and I can find I clicked the wrong one. If you go to transactions clean, you can see how it was created. You can see the logic. You can see the provider that created it. You can see all this stuff from here. You can create more complicated transformations. So like in this situation, I'm creating another transformation, which is percent balance, which is take the amount of the transaction divided by the balance. You can see that this PyDoc here, right? It actually, we parse this PyDoc and the variant and everything. So if I go back to my dashboard and look up percent balance, I can see the code that defined it. I can see when it was created. I can see the description, which is the exact PyDoc I have here. If I was to change this or update it or create a new one, I can see that as well. I can also preview it. I can see different metrics around it if I wanted to. So I create table, view metrics on it, but all that kind of comes built in. As a comparison point, so just to give you an idea of how different feature stores are, I also created a feature in Databricks' feature store, which is a literal feature store. So if I look at this feature table, you can see where it was created. And if I go to balance percent, which is the very similar, that data set, that feature, this is all the information I get, which isn't much. Like this is almost not useful. Like if I was to give you as a data scientist, hey, I have a feature, it's called balance percent. Here's all the information about it. You get no lineage, you get no code, you get no preview, you get nothing, just this. And in practice, that's not really that useful. So with Featureform, all of the lineage, the logic, everything is built in to the feature definition, as opposed to just treating it as a column in a table. It's actually treated as a DAG, as a definition. So I'll go back to my workspace. Now, you can see I can also do more complicated transformations. Like this is a windowed aggregation where I'm taking the last 30 things the user bought and I'm calculating the mean. Now, this will be constantly changing as new things come in, right? What's kind of cool here in Featureform is after we build these data sets, we can define the specific features and labels that exist. So a feature is a 2 or 3 columns. The columns are the primary key, it's like the entity key, the value, and optionally the timestamp. Now, feature values change over time. When I have a label, like I'm trying to predict, is this transaction fraud? And the fraud happened 6 months ago. I need to know what the value of the features were 6 months ago, not now, for training. So for training, I not only need the current value of features, I need historical values of features. When I define my training set here, I specify the label, I specify the features. Featureform will automatically zip these together and do the point in time join. So we'll get the label and then we will generate the features as they would have been at that point in time and put those all together into a training set. You can see when I ran this that it starts as pending and then over time you can see them all switch to ready. So that's it. From my perspective in Featureform, I've now defined my infrastructure I'm running on. I've defined my sources. I've defined my transformations. I've defined my features and my training set. And at any point in time now, anyone else, so another data scientist can go and use any of these features, any of these data sets, anything I've defined in Featureform is fair game to use. All of it's being monitored. All of it's version. All of it has lineage. All of it's searchable. And if we had this configurative governance and other things, all of that would be enforced as well. But from your perspective, as a data scientist, the only difference is that you tab it over and you put in a function and you give a little bit of metadata. That's all you need to do, and you get the benefit of kind of having this stuff run in production for you with all of the things you would need to worry about. And it's really easy to use. I mean, obviously now that we defined this thing, these features and training sets, we want to use them in a model. And that's really easy to do. So here, I can specify client training set. I can specify the name, the version, which I defined here. And optionally, I can specify a model, which is a string. Now, the point of the model string is so that if I go back here, I don't know if I actually ran this, you can actually look at the model and see which training sets the model was trained on. And when you serve features, you can do the same thing. So that's a huge benefit of Featureform. You can get lineage all the way from the model back to the data sources. So we can get that train set and call .data frame. And we get that training set, this whole training set we built as a data frame. You can also get a data frame as a stream of features, or sorry, rather a stream of rows. So if you were doing like mini batch training, you can do that as well. Training is really simple. Like we'll set up our data frame for distributed training, which is what we're doing here. So this is very like Databricks centric. Like this has nothing, at this point, I'm just working with data frame. Like from PySpark's perspective, from Databricks' perspective, at this point, Featureform doesn't really exist anymore. And that's by design. Featureform starts where the model starts. We tried not to encroach on how you train your model and how you use the features and the training sets themselves. So here, I'm creating an MLflow run. I create my Spark classifier. I specify my features and my labels. I fit my model to the training set I built. I can also log my feature columns in MLflow so that I can go back later and actually get those. And then when I ran this, it built a model. And I can actually go and see that model in Databricks. So I can go here, I can see the model I have, and I can see the different versions, if there were many versions, and all sorts of stuff. I later created a serving endpoint. So I picked the model, and then I created a serving endpoint for it, which you can see here. So next, I'm going to show you how to serve. So I showed you how to train a model. Now, we also maintain a cache of current feature values in Redis, right? Like when I define my features, I specify the inference store as Redis. And that means that Featureform will automatically materialize my features, the most recent value of my features, into Redis. Like how I showed you that production slide. Like these are batch features in Databricks, and I specify the inference store as Redis. So if I was to set up a schedule, this thing would run on the schedule and it would build a training set while also updating the Redis cache with the most recent value of features so that when I make a request, I can get the most recent values. Now, one of my features, if you remember, is the percent of the transaction, or sorry, rather the transaction amount divided by the balance. Now we have an issue here because the transaction amount, I won't know. Like in training, I had the historical transaction amounts of the transactions, but moving forward, I won't know what the transaction amount is till the request. And so again, looking at the different types of features, this would be an on-demand feature. It's a feature where I would have to use data from the request. In this case, the transaction amount, which is a parameter. And I can do that very simply here. I can define an on-demand feature. I call on-demand percent. I return the transaction amount, which will come in as a parameter, divided by the balance feature. Now I define this on-demand feature, and I apply it. And you can actually see this, again, all the types of features, including on-demand features, you can see in the feature store. You also get some level of monitoring and other things on it as well. And when I want to use my features or serve my features in production, I call client.features. Well, client.features, I specify a list of features that I want. Could be the average transactions, on demand percent in this case. I specify any request time parameters. So transaction amount is a request time parameter. I specify the entities that this is associated with or that I need the features for. So in this case, the user. And that's all. And I call client.features, and I will get the feature values of average transaction on demand percent for that user, which I get in a NumPy array called F. And again, I can do whatever I want with this NumPy array. Now, in this situation, I will have already deployed a serving endpoint of my model that I trained in Databricks. And how that works in Databricks is that you get a actual endpoint, which you can serve to. And you specify your Databricks token, you specify, you turn that. So the way Databricks style works, you would put it in a dictionary with instances, and then you would dump it to a string. That would become the body, which you can see here. And that's it. Then you call request.post on that URL with the headers, with the body, and that will actually make a prediction on your live running model. So in this example, I've now defined not only my features, I've defined like here, like if I, the other thing I didn't put here, which I can show just to give you a sense of it, I didn't put the model name. But if I put the model name here, which I think I called it earlier, Databricks XGBoost, and I run this feature, you can see even in the dashboard now that for Databricks XGBoost, you should see the features that have served to that model. So I can actually look at those features. I can see how they're defined. I can go through the lineage. I can see who built it. I can see what providers it's run on. I can see the other sources. I can preview the data if I wanted to. And yeah, that's Featureform. Any questions on these last 5 minutes? Lost my Zoom. There it is. Okay. If there are any questions, feel free to throw them in the Q&A. I'll wait a few more minutes. If not, very easy to find. I'm Simba at featureform.com. And we also have a Featureform community, which Shab will send in the follow-up email. But you can join if you want to keep up with things, you want to stay updated with Featureform. It's a great place to do so. Shab, anything I'm missing out?
No. Like Simba mentioned, I'll be sending out a follow-up email that includes a link to the recording in case you want to review it or go back or share it with anyone, a link to our Slack community, and also a link to our upcoming events as well.
Cool. And awesome. In that case, thanks everyone for hanging out with us, and hope this was useful. Thank you.